So imagine you lived in a world where there was no clean drinking water. All of the lakes and rivers were contaminated, as well as all of the groundwater. Think about what would happen to the cost of living if all the water that we drink had to be heavily sanitized. Would there be enough water for everyone to drink? Would the price of water go up? Would people not be able to afford water? My name is Quinton Allen, and I'm going to inform you today on the effects of synthetic fertilizer on our environment. My goal is for you to understand exactly what synthetic fertilizer is capable of. I'm currently pursuing a degree in soil and water science, so I feel that I'm capable of giving you more in-depth information about this topic than maybe other people could. So I'm going to break down my speech into three main topics. First is the general information about fertilizer. The second will be how soil interacts with fertilizer. And the third will be the effect that fertilizer has on water. So first we're going to talk about fertilizer. So as you can see, and probably know, fertilizer is a household product that is used to keep your gardens or yard lush and green. It's usually sold as a granular or pellet, and that makes it nice for when you fertilize your yard. It'll slowly dissolve as you water your yard, continually fertilizing your yard, prolonging the time between having to fertilize it. And if you've ever bought fertilizer, you've noticed that there's three numbers on the front of the bag. According to Growing a Greener World, the numbers represent the percentages of the key nutrients that are in fertilizer. The first number represents the amount or percent of nitrate that is in the fertilizer. The second number represents the percent of phosphate that is in the fertilizer. And the third represents the percent of potassium that is in the fertilizer. So as you can see here, I have the chemical formulas for the three nutrients that are in fertilizer. And as you can see, nitrate and phosphate both have a negative charge, and potassium has a positive charge. And that's going to play a big role in its interaction with soil. So, on to my next topic, I'm going to talk to you about soil. And soil consists of three components: silt, sand, and clay. And the varying amounts of the component decide what kind of soil it actually is. So clay is really the only one that interacts with the soil, so that's what I'm going to talk to you more about today. And as many people probably don't know, on the microscopic level, clay is almost like a book. In one particle, it consists of a bunch of little layers that are all stacked on top of each other, as you can see in this picture here. And they're very good at storing minerals and nutrients in between the layers. And in a peer-reviewed article on soil electrical resistivity, they go into great detail about the cation exchange capacity, which is the ability for clay to be able to store positively charged ions in the inner layer space. And what that means is that since clay is negatively charged, the only minerals that it can hold are positively charged, such as potassium, which means the phosphates and nitrates that are in the fertilizer just leach through the soil and keep going down every time it gets watered. At this point, one of two things will happen. According to the U.S. Geological Survey, the fertilizers will either continue to leach down until they hit groundwater, in which the nitrates will contaminate our drinking water, or they'll hit a water table and begin to move horizontally until they hit a lake. And when they hit a lake, it can cause eutrophication. And eutrophication is when the phosphates that enter the lake are eaten by the microbes and cause an algal bloom. And while they eat the phosphate, they deplete all the oxygen that is in the lake, causing everything in the lake to die and algae to form on top of the water. And so we are taking measures to help prevent and slow these two things from happening. In Pinellas County, for example, in the Pinellas County Code of Ordinance, Article 10, they have placed a ban on the sale and use of nitrate and phosphate-containing fertilizers between June 1st and September 30th. And this helps a lot because during the rainy months, which is June through September, they don't allow any nitrates or phosphates to be in the soil. So I'm going to give you some last key points to remember. That fertilizers do contain potentially harmful ingredients such as nitrate and phosphate. They do not get stuck in the soil, so they continue to leach down until they hit water, and they will contaminate the water. So I hope by this point you've begun to realize the potentially harmful effects that soil can have on our drinking water, and that fertilizer should be used sparingly in order to preserve our clean drinking water. So I'm now going to open it up to any questions that any of you may have, any lingering questions for my speech.
What are the interactions between the fertilizer and the silt and sand?
That's a good question. So whereas clay is made up of little tiny sheets and has a charge, sand and silt do not have a charge, and they also are solid particles. They don't have any sheets. And so sand is used as a way to aerate the soil, and silt is more of a way to hold water, and whereas clay holds the nutrients and the water. So the silt and sand don't actually interact with the fertilizer at all.
Thank you.
Are there any other questions?
If nitrates and phosphates are really bad, then why are they still legal in other places?
So nitrates and phosphates are still legal to be in our fertilizer because it's what keeps plants green and lush. But they have to be used sparingly. In small doses, they don't cause any harm. But if they're used in excess or whether they're used during the rainy months, that can have a big impact on whether they can contaminate our drinking water or not. So if there's no more questions, that will conclude my speech. Thank you.